Oh, hey, look, here we are. It's me, John Park. It's time for another exciting episode of John Park's Workshop. Today, it is action-packed and filled to the gills with lots of different projects that I'm working on, that I'm kicking off, that I'm wrapping up, that I'm just starting guides on. So I'm going to fill you in on all that. I've got some tooltip kind of software stuff I want to show on a 3D modeling thing I'm working on. I've got a fancy new coupon code for you. I don't know if it's all that fancy, but it's new and it'll work for you to get a little bit of a discount on your order. What else? I've got a CircuitPython parsec for you. I've got a product pick wrap up. I think there's even more. I have some retro gear stuff I want to show. I have some new gear report stuff I want to show. It is a veritable smorgasbord of stuff today here on the workshop. So thanks to you for stopping by. I couldn't do it without you. Hello to anyone and everyone in our chats. If you're wondering where the chat is, we are keeping an eye on our YouTube chat. And then we have our Discord. So if you're in one of the other places like Twitch or Facebook or somewhere and you're wondering where the chat is, maybe you could head over to adafruit.it/Discord, jump into our Discord, look for this channel right here, the live broadcast chat channel. That's the one with the big tooth in it. Sorry, Andy. Andy lost a filling. But here it is. Here's where the people are hanging out. So come on by and chat with us. If you've got any questions for me during the show, or if you've got some stuff you want to talk about or you want to answer questions, this is a great place to do it. So head over there to our Discord. Let's see. Next up, why don't we talk about a little coupon code that I've got for you, and that is this right here. It is so incredibly not hot and pretty gloomy here in Southern California that I have now dubbed it Junevember, because what the heck? Super weird. What's happening? It's been cloudy and kind of cool. And this is Southern California. It's usually kind of very hot. But either way, you can get yourself a discount code, a discount using this code, I should say, over at Adafruit. So jump on over to Adafruit. The main page will get you right there. Adafruit.com will get you right to the store. You can look for some stuff. You can search for things. You can go into the products link and go to categories. You can just click on View All New Products if you want to look and see what's new. You can scroll down, browse around, and see if there's something you want to get. And then on your way out, just throw that coupon code at the cart, and that'll drop the 10% off all of your goods, all of your things. It won't work on software, gift certificates, or subscriptions, but it will work on stuff. Also, we have a bunch of freebies available. So if you go to adafruit.com/free, Yeah, like that. You can see we've got a free PermaProto half-size breadboard PCB if you get the $99 or more. And these stack, so you can get that, and a free KV2040 dev board, excellent for keyboard and macro pad projects, and a whole lot more if you go to the 149 level. For $199 or more, you'll get free UPS ground shipping in the continental United States only, sorry. And then if you do a $299 or more order, you'll get a free Circuit Playground Express and the free shipping and the KB2040 and the PermaProto. So it's a bunch of cool stuff you can get just by ordering. And you can also get yourself a nice little discount if you use the coupon code JUNEVEMBER. So yes, that is not to be confused with Octuary or Decryl, says Andy Calloway over in our chat. Absolutely right. So hello, and thanks for stopping by to Yendor MC over in our YouTube chat. And yeah, Dave, Odessa, I have not yet gotten to the 1080p broadcast. I just ran out of time this morning to set that up. But actually, I hope I can do that for the next product pick of the week video, because I usually have code in there that you want to look at, some CircuitPython code in there you want to look at, or Arduino code. And speaking of which, I think that's a decent segue right there for that. That's JP's Product Pick of the Week show. I do that on Tuesdays, and I bring you something like this. This was this week's product pick. Usually chat about it, show you some demos, take you through some code examples, and here's a little 1-minute wrap-up of that. The NeoDriver I2C NeoPixel board. This is the Le Potato from Libre Computing, and this can't drive NeoPixels on its own. I now have the NeoDriver board plugged in over I2C to the Le Potato, and then I have power coming from a 5-volt DC supply, and then I have a nice NeoPixel strip, about 60 NeoPixels, plugged into these little terminal headers here. This is using Blinka. That, and rerun it. And here you go. This is not slow. At first I thought, uh-oh, this is, with all these warnings, is this going to be disappointingly slow and we're going to be sad? But no, I'm here on a little single board computer that can't on its own do NeoPixels, and yet with our little NeoDriver, we are doing some very respectable NeoPixel driving. Is the NeoDriver. It is an I2C Stemma QT NeoPixel board. Yes, indeed it is. So let us know if you grabbed one or more and do some cool projects with them. I'd love to see examples of that on single board computers, on RP2040s where you're already using up all your PIOs for other stuff and you don't have any left for bit bang in the NeoPixels. Cases like MacroPad, where you can use the I2C and get some NeoPixels externally, as well as some other sensors and things, other inputs. Let me know. Let us know in the chat. All right, so that brings me to, let's do a CircuitPython parsec. CircuitPython parsec. All right, let me grab the Moo editor there. I don't use the Moo editor a lot, but it's got this great plotter in here that I wanted to use in this project, and it's nice to be back. So first of all, I'll say the frame update is not great. The screen capture of this is not great. So I have kind of what looks like a clunky looking sine wave moving by there. It's actually pretty smooth in real life. But here's what I wanted to do. For the CircuitPython parsec today, I wanted to show you how to use the absolute function to create a fully rectified sine wave. So what is that? What does that mean? Right now, if we use a typical sine wave function in CircuitPython, we're going to get positive and negative values moving above and below the 0 line. So maybe that's something you're using for voltage or using for a color value. In some cases, you may want to just go from 0 to a positive value down to 0 and kind of bounce right back up to a positive value again, never go below 0. So this is often in electronics something that's used to take voltages that are going positive and negative and just get the positive voltages out of them with something called a full wave rectifier. Well, we can do that simply by adding the absolute function. So if you look at my code here, what's going on. I'm importing time, the board definitions, and math, so I can do that sine wave. And then I'm doing 100 steps of getting values on a sine curve. Then I'm printing those out, and I'm printing them in a way as a tuple so that I can see them in this plotter here. What I've done now is uncommented this line where I'm, instead of showing the value of s, or the sample of that sine wave, I'm going to show just the absolute of it, which means we're never going to go negative. So if I go ahead and save this code on my feather there and rerun it, now you're going to see we have basically just the top half of that sine wave, and whenever it gets to 0, it brings the value back up again. You can see the plotter just adjusted to the new range automatically. And so this is a way that you can take a sine wave and turn it into a rectified, only positive values sine wave, which can be useful for all sorts of things, such as bouncing the color values or the component of a color value in a neopixel, maybe some things to do with motors or sound. There's a lot of cases where you can use this. And so that is your CircuitPython parsec. One other thing I wanted to show is you can actually do some kind of fun stuff with making waves that are partly a regular sine wave and then one cycle of this, this partial sine wave. If we go ahead and just copy this code here for a second, I'm going to paste that block below. And let's say we'll just do half of that, 50 samples of the absolute and 100 samples of the full sine. Go ahead and save this. Now you see we get these little peaks. These can sound really interesting if you're using stuff like this in audio waveforms to get these sort of interesting harmonics that you'll get with partial and full waves. So there's a lot you can do. Yeah, someone said a Python diode. That's right. We just want to block all that negative stuff. Block all that negative energy with absolute function. That's really the point. That's the takeaway here today. All right, I'm going to close that plotter. By the way, you can see over here on the side we were getting also the values to print out. So those were, you can see the values are negative and then only positive, negative and only positive. So let me close that down. All right, let's see, what have we got next? I'm going to look at my notes here. What did I say I was doing today? Because I've got a whole bunch. Since I've got the downshooter set up right here, and I'm standing right here, let's do a little gear report sort of thing. Just because this news came out yesterday about Grimace's 50th birthday. So any of you who are familiar with McDonald's may know that Grimace, the big purple character there that they've got, turned 52 yesterday. That was his birthday. And they put out a Game Boy Color game. Let me adjust the focus here real quick. Get it up to about there. Yeah, okay. So I wanted to show you the Grimace game playing on, this is an emulator called a Miu Mini Plus. I got this recently and I'm really liking it. You can see they've gone for a Game Boy style form factor on this, as well as the sort of color way that I've got. I'm running an alternative OS on here called Onion OS that's really nice, very customizable. And if I head on over to games, you can jump over to the Game Boy Color emulator, and you'll see here's Grimace's birthday, version 1.2. This is free, you can download. Look, there it is, there's Grimace's birthday. My color rendition is terrible here. Let me see if I can adjust the exposure a bit, and maybe white balance. That's closer to it. It does not pick up the fact that that's a very purple, unfortunately. Grimace is purple and not blue. So I guess I've shoved that over into the warm tones enough. So here you go. Here's Grimace's birthday. I'm sorry, I'm not meaning to advertise terrible for you fast food. I really am not, but I do like the fact that a brand new Game Boy Color game just came out in the year 2023. All right, so we'll jump to the game. Hey, look, there's Grimace. Cute little animation. He's got to find his friends. He's got to get a purple shake. And the best way to do that is by platforming on his skateboard. I don't really know a lot about Grimace lore, so I'm not really sure what how this fits the canon. You got jump trash cans. Oh no, that's terrible. I hit a trash can. Let's see. Oh, that's. I think I've got. Do I have auto exposure on? No. I don't know what's causing that to adjust itself. But anyway, yeah, a little grinding, little trash can again. All right, I'll get out of there. But partly I also wanted to mention this thing is really cool. This this Mew Mini. There's a few of these types of. Let me turn the volume down on this. Handheld emulator types of consoles out there. This is a fairly new one and seems to be a pretty nice one. It's got a decent processor in there, pretty fast. I think it's an ARM. I might be wrong on that, but I think it's an ARM processor in there. And you can do a lot with it. There's different apps you can get on them. It's all running off a little SD card there, has the USB-C. This one's called the Mew Mini. I think these things are around like 70 bucks. Yeah, sorry, I just got a note that was looking pretty dark, so I tried to brighten that up. I can jump right back. You can, there we go. That's a lot brighter. You can see that better now. Let's go back to that game. There we go. Yeah, there we are. So I didn't look into this too much, but the studio that designed this and created this for McDonald's, I think, has a reputation for doing these new games on old consoles. They're mentioned on the startup screen, but sorry, that passed by. I didn't see it. But go look. There was a bunch of articles yesterday all over the place because, hey, how cool is that? You can also play it in browser, but playing it with actual hardware, D-pad, buttons like that is really the way to go. So there it is. That is the Grimace's birthday game on the Mew Mini Plus. These things, by the way, these modern emulators, they're pretty cool because they do things that the original games don't do. So things like save states, even if you don't have them, you can play through games a lot easier using save states rather than whatever the save mechanism or password mechanism for saves was in the game. So these are pretty cool. Anbernic is another really popular brand. I've never played with one of those, but got this one recently, and I like it a lot. All right. Okay, yeah, thanks for the note about the screen being too dark. Hopefully that was a little bit better. Next up, what have I got? Let's do a kind of a wrap-up on this thing here. I showed the PlayStation roulette and regular controller yesterday on Show and Tell. Let me see if I can jump to this view over here. Yeah, let me jump over there. So the evolution of this was that I had a Raspberry Pi Pico that I was using to read the controller messages from PlayStation controller, and these are all fairly standard, even though this one looks a lot different than this. This one acts identical to a PlayStation 1 or PSX controller. This is a PlayStation 2 controller, and this is one that adds the option for analog. If you press that button, you can read these analog potentiometers, as well as there's a left 3 and a right 3 button you can click there, but otherwise they send pretty much the same messages. And I had been using one CircuitPython library that was out there. I had some issues with it that made it a little difficult to read these sort of rapid messages or hold messages that this sends when we spin the spinner on the roulette. So Todd Kurt, thank you. Our great friend Todd decided to write a PlayStation 2 controller library for CircuitPython based on some existing ones in Arduino that he credited. The library Todd wrote, PS2 controller library, is now in the community bundle. So you can, if you're using CircuitPython, you can go CircuitPython install PS2 controller, and you'll have it up and ready. And there's some good example code for that. So I got that running, and then I converted my pinouts to use a CircuitPy RP2040 rather than the Pico that I was using, just to make it smaller, and to also to get USB-C, because I love that USB-C. And then I went ahead and grafted that CircuitPy onto one of these PlayStation controller extension cords. And so these essentially have a female and a male end to them that you can cut them in half. This is what they look like normally. So you'd plug a controller in here and this into your console. Obviously, I've cut a lot of wire out of here. These are usually really long so that you could, before the age of wireless controllers, play these on your couch, play your games on your couch. So what I did is I went and wired that pretty much same wiring you see here. There's 4 data lines or clock and data that matter on the PlayStation controller that I have going into pins A0, 1, 2, and 3. And then we have power and ground. There are 2 other pins that are basically not used in this case. There's a rumble pin if you want to send power to the rumble motor. And there is an acknowledgement pin that I think is used for bidirectional communications, but it's not something that's, I don't know if it's never been implemented, or at least is not common in some of these more modern libraries. So with those pins soldered onto the CircuitPy, I then shrink wrapped it to make it a nice, neat little package, and now I can simply plug that into USB and plug any PlayStation controller in, and I can then use CircuitPython to send out USB HID commands. In this case, I'm sending out just HID key letters like WASD for the D-pad, and so on, and those are then interpreted by whatever you're playing on the other side. You can play emulators with them, or like one of the examples you've seen me use, I'm doing mouse click, HID mouse click. When this gets pressed, it sends a burst of a lot of left mouse button clicks. I also put a little pinhole prick in the heat shrink there so that we can see the status LED light up. So let me zoom in here. Try to focus that. So you should see a LED blinking there. So that shows me that it's waiting for the controller to show up. Since I'm also doing USB HID stuff and I'm not plugged into a computer here, this is just USB power, it's never going to actually run, so it didn't go blue, but I have it going to blue, which is kind of a nice PlayStation 2 color when it gets there. So just a little hole in the heat shrink. Also, a tip I wanted to show you for this is that sometimes you will run into a case where your heat shrink is just about, but not quite big enough to fit over what you're using. So just given a little bit of the extra bulk there of the ports and stuff, this heat shrink wouldn't actually fit on there. You can stretch it out pretty well, and then heat shrink it back to size. So if you take a piece like this, cut it to size, what I often do is just put my scissors back in there and pry that open. You can see I've just expanded that probably 15% or something, and that was enough to get it over that CircuitPy there. So that's not a official on-label use of heat shrink tubing, but when I'm desperate, I do that, and I don't have enough sizes of heat shrink around to always be able to do that. So, and that may have actually started to already flex back down to size. So let's see if I can get it big enough to put essentially a second coat. There we go. If you're not careful, you will just break it, but there we go. Now we're, whoop, like that. Hit it with your heat gun. I recommend a heat gun, maybe even a hairdryer in a bind. You could probably do it with a lighter, but I'd rather not light some of these things on fire here. So heat gun is pretty controllable for that. So that's a little bonus tip there for getting those to work. So I'll be writing up the guide for that. Should be out pretty soon, and that'll be both, I think, useful for kind of generalized PlayStation controller use. They're really nice controllers. It's like I said, PlayStation I don't have one right here right now, but that's the kind of the gray one. Has no analog pads. And then the PlayStation 2, I think there were a couple of variants on PlayStation 2 controller, if I remember correctly. And I can't remember if one of them was like a simulated analog and the other is the real analog. But the button there switches those modes to analog or digital, and then the library that Todd wrote allows you to also take in the full longer message. I think it's 16 bits if you're using the analog and just 8 if you're using the digital, so it's a little faster maybe. So haven't seen that too often in CircuitPython, but these are great controllers. You can get them cheap. You may have some already, and they're excellent for all kinds of projects. Get a bazillion buttons and even these analog pads here. All right, so that is that project. Next up, let me go back over to where I can see the chat and see if we've got any questions. Let me jump over here. All my complaining about the weather, now it's actually kind of starting to warm up a little bit, so I'm going to roll up my sleeves here. Yeah, see, Grover, we avoid open flames in the workshop. This is a good policy. Agreed. Okay. Yeah, thanks, Toddbot. Toddbot said, yeah, it looks like a real project. Definitely heat shrinking that down to black and hiding it, the guts of it helps a lot. You could probably also do, a little case for it, 3D printed thing, a little project enclosure if you wanted to. But heat shrink at least gets you part of the way there, I think. All right. So next up, I want to show. Speaking of enclosures, actually, let's talk about this project here. I'm gonna take you to. Let's do Dinky Auto Shop Home. Do you have it on the shop? Yes. Okay. So our friend, OK, you're on, Steve, also known as Denki Auto, is over in our chat there. Hey, Steve. Steve makes all kinds of cool stuff, all kinds of music instruments, gizmos, music computers, things related to music on Raspberry Pi, other things, MIDI stuff. And this is a project he's been working on that is essentially a Raspberry Pi shield or hat, or whatever we call those these days, that breaks out gives us a really good analog, or rather a codec for music, for sound. Gives us inputs and outputs for audio, as well as some key switches and encoders. And this is based on the Monome Norns and Monome Norns Shield projects that are out there. You can read more about it here. There's a little link in the notes there. So this, Steve asked me about doing a case for this thing. This essentially goes on top of a Raspberry Pi, and then what? And then you need it's got a display that goes on top as well, so you need a case of some kind for it. So I just wanted to show you a little bit about the case I'm designing for this. It's also kind of a general purpose, hey, I want to design my Raspberry Pi case or my Raspberry Pi plus other stuff kind of case. And I am doing that in Rhino, so I thought it might be fun to show you a little bit about how I'm working on that and where I've gotten with it. And then next week I'll probably show some interesting little gotchas in my design when we start 3D printing this that I'm going to fix up. I had a successful 3D print. Steve had some fail because of wall thickness being a little bit underwhelming for some standoffs or bosses that are on there. So here is what the case looks like in Rhino. And over on the right you can see my little flow graph of how I built this. So essentially this is the operations that kind of travel from left to right here of me starting from curves and then doing things with them, filleting them to give them rounded corners, placing points that are relative to those edges. So a lot of procedural or parametric stuff so that it's easy to change our mind about stuff. So like recently we were like, hey, what if we made this slot here that gives us access to some LEDs? and a little switch. What if we made that a little wider, a little deeper? So I just have a curve that a single curve I can edit, and it updates everything. So it's sort of a parametric workflow using Grasshopper over there. So if we look, in fact, at, let me hide I'll hide the model, which I'm just previewing here kind of at the end of the whole chain. If I hide that and go to a curves layer where I've actually hand-built just a few curves. So these are the curves that were based on measurements of the actual stuff. And in a lot of cases, you'll find this is a nice, easy way, or I find this a nice, easy way to start with some real measurements, and then everything else is just built upon those curves. So, for example, this curve here, that gets a version of it made procedurally that has these rounded corners or filleted corners on them. If I want to change the radius of those, I can just adjust this little slider here, and you'll see I'm starting to get a bigger radius, right? So that's a 4 millimeter radius versus there's a 3 millimeter radius on it. Oops, I hit it again, sorry about that. So then I have operations that'll go and extrude that and turn that into the actual case. I have another curve that's also kind of inside of that, that's cutting out the guts of it with a Boolean, and on and on. So that's what the workflow for me looks like in Rhino to build that up to the finished thing. And if people are interested, I can do some sort of more basic stuff on Rhino. I know I've shown it before a couple times here and there over the years, but I think it's a nice alternative to, or it's nice to know that there's another piece of software out there. One of the things that I've mentioned before that I've loved about Rhino, which I've been using for, I don't know, gosh, like 30 years now, 20-something years now. It's been a long time. So I'm real comfortable with it, but I also have only paid for it once. They don't do the subscription thing yet, knock wood. So unlike a lot of CAD software out there where you're paying subscriptions every year, somehow miraculous. Now, I have bought it a couple times at different jobs I've worked for different companies that had a seed of it for me. But that is just, it's not cheap. I think it runs around $900, $700, $900, somewhere in there. But you buy it once and then you end up using it for years and years. It's I'm not saying don't look at OpenCAD stuff or Fusion. I'm just saying here's an alternative. It's also a fairly different, I don't know if there's any open stuff out there that's quite like this, because this is really, at its heart, a NURBS modeling package, which has all these sort of added functions on them. It's a very interesting approach that's a bit different. You can do hand modeling in here very differently than in something like Fusion. As far as I know, I'm not a Fusion expert, so maybe it's in there, but getting in there and building stuff by hand, even for quick prototypes, and then doing procedural versions in Grasshopper is certainly a big part of the workflow that can work well for you. So anyway, I don't make any money from this. I'm not trying to sell it, but yeah, so $9.95, Rhino's $9.95. So I'm not telling you to jump out and grab this if you're a hobbyist. There are, I think, educational licenses if you're in school, but I want to be able to show this. You can, of course, apply a lot of these concepts. To be honest, a lot of what from the bit I've used, Fusion 360, a lot of the sort of workflow is really similar. You kind of go into a drawing view, you build some drawings, you constrain them to things, to measurements, and so on, and then you add stuff, you fillet stuff, you cut stuff out, you fillet those edges, and on and on. This is sort of a visual representation over here of that whole workflow, and that works well for me, again, just kind of based on the type of VFX software that I have used for a long time, like Maya and things like that. The ability to see a flow graph of how things are put together is nice for me. Also, one thing I really love is, I'm going to go ahead and hide everything in here. I don't have any shortcuts set up on this one. One of the things I really love about Rhino is the renderer has some really nice, oh, I don't have my custom, I have a custom just ink line renderer that I like to use. This is a really similar one that'll show up here in a second. Hopefully it renders well on the broadcast here. It's taken its time, but you can do some really good presentational renders that show off the sort of clean lines of your project and the occlusions. But it's going to choke on this for a little while here, so we'll see. Let me know if you have any questions about this, by the way, in the chat. I can jump over and look at while this cooks. Oh, Todd said Rhino gives you a 90-day trial. Yeah, so get you hooked and then pay your $9.95. Oh, I don't have any idea what graphics settings I have set up on this machine either. This was a mistake to try to show that. I'll get away from this screen. I'll come back if that's come back on. In fact, what I'll do, oh, there it is. Ah, finally. Yeah, I don't know what took it so long, but yeah. So I love these. These are really clean and clear for showing people stuff because it occludes stuff. It shows you sort of silhouette edges and edges that aren't occluded. It's a really good way to, I think, to view models when you're getting feedback and sharing them with people. So these little four here, these are where the Raspberry Pi goes. What I thought I'd do now is just show you the model as is right now and some of the parts here. So this is, let me clean up this camera view here a bit. That's a little better, yeah. So this is a set of 1/4-inch audio in and out jacks that'll be soldered under here, and that's what these big holes in the back here are for. Here's your sort of typical Raspberry Pi stuff. So you've got the ports in the back, you've got the ports on the side that are for the Pi as well as for the shield. So the shield will sit on top like that. So there's the Pi, and so what I've modeled here, and be careful of that SD card, let me take that out, are these four standoffs so that this is just lifted up off the ground a little bit. You can see I put some vent holes in here. So this will go on like that. I've got some countersunk holes for M2.5 screws that come up through there. These are tight enough that they sort of thread through those standoffs, and I actually put threading in the model, not that I'm printing at a resolution where that really matters, but those will then go to some standoffs that you can see here on the bottom of the shield that'll go. So if you basically ignore this half, this is a pretty typical Raspberry Pi shield with a little space for your SD card and lots of space there for, this is a Pi 3, so we have a big HDMI port on there, but this will work with the 4 as well. And then I have built the bosses into the wall here to keep them nice and sturdy and stable. And I think I'm going to do that on the right side of the Pi as well. So those just rest right on top of there. No need for extra standoffs, and then the screws will come in down through the top. I think also some other standoffs, and then we'll have our screen here. Steve's got a laser cut top design that goes on top of here. In fact, I think I just, in this model, added my own just so I could visualize it to make sure I was getting things right. So if we look at the baked out top panel, it'll look something like that. So there you can see we got space for rotary encoders, key switches. These use chocks, and you can also use Cherry MX. Steve designed a footprint for both, which is awesome. So if you look at these little chocks here, you also put a little PCB under them to just get their height up. So those were a little low. They're very low profile. This was actually too low profile. There we go. So those will go in like that. And if you've got do I have a Cherry MX? Here's a Cherry MX switch. That could go in the exact same spot there because he made a sort of ambidextrous footprint, which is pretty cool. So those will go in like that, rear encoders, and now we'll have a cool little Raspberry Pi-based sound computer that you can, if you look at Monome and look at the Norns project or the Norns Shield, this follows the Norns Shield almost exactly as far as should be the same software. Thanks. Oh, Steve posted an incline render up above in our chat. So yeah, if you look at this, actually, this is where Steve had already modeled the shield and a Raspberry Pi, and I modeled a screen and we grabbed some knobs, threw that stuff on there so that we could visualize it. So that's really helpful, I think, for figuring out if you're making the right thing. All right, so that's the Shield XL case work going on there in Rhino. Put this off to the side. I also, by the way, here's a tip, something I did to make my life easier as I was testing some iterations of these side holes, which were originally a little more conformed to the ports. I didn't want to print the whole thing, which was taking about 4 hours, so I think this took more like an hour, and I could have chopped that off if I were just testing bottom stuff. But if you just hack your model into pieces and test little miniature bits of them, you can iterate a lot quicker if you don't have a crazy fast printer, which I don't. So that's essentially a Raspberry Pi little sled sort of thing. I have a Pi over here. So that thing there, you could, if you just needed a little ground protection or something like that for your Raspberry Pi, a little thing like that will work. But that's just a hacked up bit of the existing model. All right. Liz said, I also use the chopping model for method for testing. Yeah, super helpful. Actually, I was wondering, are there, because I did it in my modeling software in Rhino and exported it, so I just took one, did some subtractions and sent that off. Do any of the slicers do that for you? Can you do like a clipping plane type of thing in Cura or Prusa or something and say, yeah, I just want to print this piece? I know you can sync models below the surface if you want to do that, but if you've got like a couple of sides, and can you put big blockers in and do that in your slicing software? I don't know, so I'm curious. Let me know if you know. Hey, Connor McCarter. Nice to see you over there in the chat. Hey, Johnny Bergdahl over in our YouTube chat. Connor says, has anyone played with the CAD edition for Blender? That's a good question. I have not. I haven't touched Blender since it kind of first came out, and I used Maya at the time, which was sort of a similar approach. But now they've got so much stuff in Blender, yeah, it would be worth checking out. You can do that, says Liz. Okay, so you can go into your slicer and hack away at the model. That's great. That's really cool. Prusa does in the latest, says Connor McCarter. Okay, great. Love that. All right. So let's see. Let me look at my list here of stuff I wanted to talk about. And before I go too much further, I will remind you, if you want to go buy some stuff on a discount, June-vember. That's my gloomy, why is it so gray in Southern California code. Poor little me. But June-vember, it's not June, it's not November, it's June-vember. That'll get you 10% off in the store, so head on over to adafruit.com. Chuck some stuff in there and get yourself a nice discount, 10% off with June-vember. Okay, next up. Oh, I'll just mention this, nothing to show, but once I finish the guide for the PlayStation controller adapter, I will be getting to work on a SynthIO guide. So Jepler started putting a Learn guide together with some of his notes. Toddbot is doing a whole Toddbot SynthIO cookbook, which is fantastic. I'm going to try to do just a more straightforward, hey, here's some of the basic blocks of how we use SynthIO, maybe do some audio examples. So that'll be a couple of resources between that one and Toddbot's cookbook. Hopefully that'll get people answer the questions you may have if you're wanting to make synthesizers inside of CircuitPython using SynthIO. Also, Lamore and I were talking about just yesterday, talking about maybe trying to do a most minimal possible MIDI synthesizer we can in CircuitPython. So if you've never seen the, what was it called, like Tiny Synth in a Plug, let me look this up and show you. tiny synth in a MIDI jack. Mixela, M-I-T-X-E-L-A. There it is. Okay, let me show this. So this I will not be making it this small. This is amazing though. This is you can see a picture there of a typical DIN5 MIDI chord. On the left there is a full-blown synthesizer that has, I think, I think it's got a jack on there for like an 1/8 inch or 3.5 millimeter audio out. I think it gets its power off of MIDI. So anyway, inspired by that, I'm gonna try to see how minimal can we get with maybe some of our audio BFFs and a Qt Py to do a little plug a MIDI keyboard or controller into this, plug audio out. Can we run it off of the MIDI 5 volt? Who knows? We'll find out. How small can we make it? Not that small, but we'll try to see what we can do with off-the-shelf parts in a reasonable fashion. So that's going to be the mini MIDI synth project using CircuitPython. That'll be coming up. Another one I've got here. Let's. This is a bit of a gear report kind of thing, a retro gear report kind of thing. I'm going to jump back over here, and let's go to that view there. Let me get those scissors out of there. So I recently saw someone selling a $35 a MicroKorg synthesizer. This is just part of it. The key bed and the case are laying over there. But the MicroKorg is a really cool synth. They've been around for like 20 years, still kicking it. And this one is completely non-working. So one thing I love about it is this gorgeous metal faceplate with all of the kind of the guide of what all these rotational selector switches, different presets. This one's kind of famous for having presets that are listed in music genres: trance, techno, house, electronica, drum and bass, breaks, hip hop, vintage, retro, SE, hit, and a vocoder. This is kind of famous for having the vocoder on it. Anyway, a really nice panel there. I cleaned that up and it's in great shape. No scratches in it. I just kind of wiped off some dirt and things. Here is pretty much the synth, other than the key bed. This is it right here. You can see there it's got MIDI jacks. It's got audio in and out, pedal, microphone, DC power. This is kind of the key to our woes here. Has a typical DC power jack. Can run off of batteries too, and I wish the previous owner had only run it off of batteries, but then they wouldn't have been selling it to me because it wouldn't be broken. I think what happened was this is a center negative 9 volt power requirement on here, typical of like a guitar pedal. I'm guessing someone plugged in a center positive 9 volt adapter into here, maybe a center positive 12, maybe 18, I don't know, because when I opened this up, I saw scorch marks on the inside of the case, and if I zoom in here, there were a couple of clearly missing and exploded capacitors. So the electrolytic caps that look just like that one, and that one looks a little bulgy, so I may replace that one too. But if you look right here, there are some traces lifted clear off the PCB, scorch marks, solder spatter. So anyway, hopefully this did not blow away some of these ICs, some of the microcontrollers, DSP, that stuff, because then it's hopeless. I'm not going to be able to fix this. If some of these fuses blew along the way and it just murdered the capacitors, that sure would be nice. There are full schematics for this. Korg is always good about this. So there are full schematics online. You can look at a whole page of just the power circuit. And so I'm going to go through and try to determine what was murdered on here. I've ordered some replacements. Again, the schematics make it really clear, and their parts list make it really clear what you've got to get. So I've got a couple of replacement capacitors. I just got a big order from Mauser, who happen to also have stuff for Steve's synth build that I need for the Shield XL. So I just got an order of both. Maybe I can repair this MicroKorg and build Steve's thing there. So that's a project. This is kind of a nice synth to look at how some of the stuff is built. For example, they've got big lighted knobs. I think this has got a little sequencer or arpeggiator on it. It's got program selection. And so they've got these buttons that are, you can see, just micro switches and big 5mm LEDs underneath. And then these custom molded, clicky glow-through switches. And those just kind of hinge back there and have legs to prevent them from pressing too hard and breaking these switches. They stop before they do that. Kind of neat. They've got a little 7-segment display there for some of your info. They're grounding this to the inside of the case with these little spring guys here. And everything unplugs neatly with little IDC style connectors there. So we'll see. Maybe I got lucky. Maybe this is repairable. Maybe it is toast, in which case some cool free parts, or maybe I can try to turn it into a MIDI controller. Who knows? But that's a little side project I'll be doing there, and I'll just update you as things happen. I won't be doing a guide or anything. There's not much to do about that. It's a weird one-off, but maybe I got lucky. It's a $300 synth for 35 bucks, and all my time and parts I have to buy. But crossing fingers, that's coming up. And let's see. I've got, oh yeah, let's bring it back over here. I've got one more thing. Today is a very one more thing kind of day. Let's see. Liz says, my MicroKorg with the broken middle A key is really fine then compared to this poor synth. Yeah. I'll show you the key bed actually on this. Here's the case. These come in different colors. They just released like the 20th or 25th or whatever anniversary edition with a crystal clear case, which is pretty cool. That just came out recently. But that's what that looks like without the nice panel on top there. All comes apart really easily too, which is nice. You can see there's a couple of potentiometers there for the mod and pitch bend. Those just plug in over that cable. And then here's a couple of connectors for the keyboard matrix, diode matrix of these keys. You can find parts for these that have been around a long, long time. You can also find sometimes that the keys in particular that get broken are available across a lot of different synths from the same company from that era in that size. So you can, sometimes it's cheaper to find a $5 broken keyboard and steal a part off of it than to go buy one for 10 bucks on eBay or something when someone's parted one of these out. But yeah, that's what that looks like on the inside there. You may think I have too many synths, but there is no such thing. Yeah, Todd, crystal clear case. Look at this, crystal clear MicroKorg. Look it. Can you see through any of it? I think so. Yeah, you can see through it. It's got those little sides. Oh yeah, on the case I just showed you, I pulled off. It has the wood cheeks, as they're called in synth enclosures. It's got little thin wood cheeks on the sides there that I'm gonna probably sand and restain. Steve says N+1 is the correct amount of synths. You can't have too many. Yeah, it's kind of not really crystal clear. It's kind of a translucent-y clear. But it's probably a lot less brittle. I think crystal clear stuff tends to be pretty brittle, right? Steve, you're a chemist. You probably know about these things. So semi-transparent, but cool-looking MicroKorg. All right. What else? is happening here. The last thing, I think, yeah, the one more thing. So I have one other project that I'm going to kick off, and this is based on these new sort of CNC jog wheel encoders, rotary encoders. You'll see sometimes people will take, I think it's called DRO kit, they'll take their CNC lathe or CNC mill, and they'll add a little computer-controlled add-on with stepper motors, and then you can, instead of hand dialing in measurements or positions, you can wheel them in with encoders. That's what these are. These are made exactly for that industry. Wheel those in, you'll see a readout, and then you can hit go, and it'll run it. So it's sort of a halfway between just sending a whole program of like G code to a CNC versus hand doing everything. There's this sort of DRO thing in the middle of it. But these are really nice encoders. So I decided to, let me see if I can show you this one running. I've just plugged it into a Stemma, not Stemma QT, but full-size Stemma port on this Pi portal. And then I'm telling those to not be I2C, because this is not an I2C thing. This is just 2 data lines, ground and power. But this is a fun hack in CircuitPython, is just telling ports to not be what they're supposed to be. So that we've got this little breakout that goes Stemma to alligator clip, which means I can just clip those to the terminal screw heads there on the back of the encoder. And let's bring Moo back, actually. Will that work? I'm going to unplug this feather, actually. You know, I don't know that Moo likes that. I might not be able to show you it in Moo. But I'm concerned, why is it just going to this blank screen? That's not what that should be doing at all. All right, let me open up Sublime Text, and we'll look at this. Hold on. Let's go here. Is it even finding it? No. All right, hold on. Let me launch Sublime Text. And darn, why did this Pi portal go away? What's your deal? Let me do reset. I don't think this is healthy. I don't think this Pi portal is healthy. See. No, I don't know what happened to this guy. That's a bummer. I kind of hard crashed this thing, I think. Don't know why. Oh well. That's okay, because all I was going to show was just the rotary encoder sending values. This thing, as you can see, it has 100 steps. And that's not just the masquerading on the dial. That's actually a 100-step rotary encoder. It has one real detente for each of these positions. And so this will really accurately, you just have to take my word on it because it all crashed, this will really accurately read out these positions. Now, these are always relative, not absolute, so you will have to have a way to say, okay, I'm going to 0 it at 0, go, and then it's going to start counting negative and positive position changes on here. So what this got me thinking is I would really like to make a safe cracking puzzle with this. So something like a little self-contained puzzle box. Could be an escape room thing too. As long as we 0 that at 0, we could then go to a safe combination spot, let's say 78, hit a button to say, okay, I'm marking that position, or just notice that we're going in a reverse direction because this can tell that. Go to another, loop around past the first number or past 0 to another number, and then have something open up. So my idea for doing that, you could do that just as a straight digital combination lock, or maybe do something using a small speaker and maybe a stethoscope, so you have to listen to simulated tumblers as if you're cracking a safe, just by sound, not by feel. So maybe haptics for feel. I'm not going to do that, but if someone wants to go the extra mile, they could add some little haptic feedback so things feel a little clicky different based on vibrations of motors or something like that. But it's too nice not to. Now, of course, these are made to spin real fast with this. I actually haven't tried, but I think you could probably unscrew that if you didn't want that on there at all. This also, by the way, has I think a sticker on here right now to keep this scratch-free. This white material, I think, comes off of there and should just reveal the same metal under there. I think. I'll find that out. But anyway, that's a future project. Once I get some other stuff done, I'm going to try that out as a fun little combination lock safe opening puzzle. Clicky, clicky. All right, I think that's going to do it. So I've got my work cut out for me. I got a lot of stuff I'm working on, but I'm excited about it. And I thank you so much for stopping by today to hang out with me and look at these fun things. Last reminder that you can get 10% off in the store today with Junevember. This coupon code won't last. It'll expire tonight around midnight, and hopefully that means our weather will become nice in LA. That's my hope. So I think that's going to do it. Thanks, everyone, for stopping by for Adafruit Industries. I'm John Park, and this has been John Park's Workshop. I will see you all next week. Bye-bye.